Just wanted to say thank you very much for joining me this afternoon, I guess it depends on where you're at. This is building real-time data and web applications with Node.js. It's part of the APAC OUC webinar tour. So big thank you to APAC OUC as well as Francisco for putting this event together. The standard safe harbor slide from Oracle. Just don't make any purchasing decisions based on what I say here today. A little bit about myself. My name is Dan McGhan. I'm an Oracle Developer Advocate. I focus primarily on the JavaScript and HTML5 communities. I have my contact info on screen. So if you'd like to email me, that's my email address. If you want to follow me on Twitter, you can do so as well. Good for the ego. And at the very bottom, you'll see my URL for my blog. That's JavaScript and Oracle. And of course, that's what I blog about there. So if you'd like to, go ahead and check that out as well. So here's the agenda for today. I'm going to start off by talking a little bit about how we got here. And then we'll talk about where we're at today. And finally, we'll get into how to mix in the database and some of these things. But before we get into any of that, what I'm going to do is a demo. And the reason I'm doing the demo first is to kind of show you the real-time data that we're talking about, an implementation of the things that we'll be going over, so you'll know kind of how it could work for you if you decided to use these techniques. Now, it's important that everybody participate. So just get ready to go to a URL. I'll tell you which URL in a moment. And let's see here. So this is the application I'm going to have you go to, and it's really 2 pages. So this is the page you'll be using, and it's the home page. I'll give you the URL in a moment. You don't have to worry about it just yet. This URL is a little complex. I'll give you a shorter one. But what you're looking at here is a listing of 20 different cities in the APAC region. And on the far left, you'll see a ranking, and notice that all of the cities are currently tied for first place. In addition to the ranking, you'll see the name of the city, you'll see the total number of votes that that city has, and you'll see a button that allows you to vote for a given city. Now, the only rule is there are no rules. So pick a city or as many as you like, vote as many times as you like, and odds are the more you vote, the more likely that city will win. You're just picking your favorite city. Now, over here, I have a dashboard page. And if you want to cheat, you can get started now. This is the URL to access the application. So just go to http://bit.ly/APAC-RT. The RT is for real time. But I'm going to sit here on this dashboard page and sort of monitor the action. And I'll just tell you a little bit about what we're seeing here on the left. We have the total number of votes that have been submitted. It's currently at 0. So you'll see this number go up, hopefully quite a bit, we'll see. And then there's updates pushed, and this is the total number of updates that the web server has given to the web browser. Oh, cool. So we have our first vote come in. It's for Beijing. Beijing's in the lead. We'll see if any other votes come in, if anybody decides to vote for any other cities. Give this just a few minutes here. Ooh, hey. We're getting more votes. All right, so some votes are coming in. Looks like Hong Kong's taking the lead with Kathmandu in second. All of a sudden, New Delhi's taking the lead. New Delhi's definitely in the lead. Ooh, they're fighting it out with Hong Kong, but Sydney's coming up strong. Sydney and Hong Kong are dueling it out for first and second place. Now, folks, while the voting's coming in, notice here what we're seeing are these total number of votes, and this is like 75, 82, but the number of updates pushed to the browser is far less. My goodness, Perth is coming on strong. It's going to be hard to beat Perth at this point. Tell you what, while you guys are rocking the vote, I'm just going to look really quick at the various cities that we have in this list. And so here you'll see, well, I'm just going to pick, let's go with, I actually was going to do Perth, but since they're winning already, I will pick Tokyo. All right, so Tokyo's ID is 16. And what I'm going to do is come over to a terminal And I'm going to put in a 16 and hit enter. And this is Apache Benchmark. I don't know if you've ever seen that before, but oh my gosh, Tokyo's in the lead. Perth, unfortunately, is probably going to lose this contest. Now, because because I've done this demo a couple times, I know that if I go on talking in this presentation, nobody's going to pay any attention to me. They're all just going to go on and continue to vote. So what I'll do instead is enable a trigger to prevent that. So here we have the trigger. I'll enable this. All right, so that should prevent any new votes from coming in. And Tokyo is the winner. Cool, okay. Thanks for participating. Okay, so let's move on and talk about how exactly the demo was put together. So we'll talk first about how we got here. And it was about 20 years ago, actually exactly 20 years ago, it was 1997, that HTTP became a thing. And HTTP was just a simple request response protocol. So the web browser would issue an HTTP request to the web server. The web server would typically read some kind of static file and then send a response back to the web browser. And this worked well and good for a while, but as things evolved, we got a little smarter and realized that we could actually mix in a database. And so the way that would work, the web browser would still issue the HTTP request to the server. The web server wouldn't respond immediately. Instead, it would issue a request to the database using a database driver, perhaps issue a query, and then the database would respond with some data. The web server would then use that to generate a dynamic web page and send that out back as the HTTP response. Now, some of you are probably thinking, actually, Dan, our applications are a bit more sophisticated. We're actually using transactions, and so our traffic looks a bit more like this, right? And you know what? We're sharding our databases globally because we're a big company. And you know what? We're also auto-scaling our web servers based on CPU and memory utilization. And we're doing all that because we got a whole lot of users. And so our traffic's actually looking a bit more like this, right? I get it. This is the reality a lot of us are dealing with today. But believe it or not, the concepts we'll be talking about, they scale up to this just fine. So we can look at it and keep things a bit more simpler like this. So at this point, once the web servers responded to the web browser, in a way, you could say the web browser is like a cache of some of the state in the database. They're currently in sync, right? But you know what's going to happen? Somebody's going to make a change in the database. Now they're out of sync. And the question is, what can you do to get them back in sync? Well, we've had for a while now the ability to communicate via HTTP from the database to the web server. That we could do. What we've not had is the ability to communicate from the web server to the web browser, issue an HTTP request going that way. That's not possible, and it wasn't possible for some very good reasons related to security. It'd be kind of scary if folks could do that. Thus began the quest to simulate pushing data. I'm sure some of the folks that are here today are guilty of a few of these. I'm guilty of 3 of them for sure. So one of them was the forever frame, and with the forever frame, you would embed an iframe into a web page, and you would use the iframe to issue requests for new data and then proxy that up to the parent page. That worked, even goes back to IE6. Then we got Ajax Polling, and believe it or not, it was Microsoft that gave us Ajax Polling, probably to make up for IE6 issues. But the idea with Ajax Polling is that when the page would load, you'd set up some kind of a timer and go back to the web server periodically and ask the web server if there have been any changes in data. And of course, the web server would have to issue that query to the database to find out. So it wasn't highly efficient. And of course, it was a full round trip, which wasn't very snappy. Then we got Ajax long polling, and this actually tended to solve a lot of the problems. What would happen when the page would first load, the web browser would issue a request to the web server for new data. The web server would not respond immediately. It would leave the connection open and only respond when a change has occurred. Now, because it was responding at the moment the change has occurred, it was a half round trip, so it was a bit snappier. and it didn't have to continually poll the database. It could just wait for the database to tell it that there's been some kind of a change. Later, we got HTML5 server-sent events, but a lot of folks really never got into them, and the reason is we got some better technologies around the same time, and that brings us to where we're at now. So some new technologies have emerged in the web world. We have both WebSocket as well as WebRTC at this point. Now, you may think this is a talk on real-time data, and WebRTC is real-time communication, so clearly I'm going to use WebRTC for the demo you just saw, but that's actually not the case. So WebSocket is all about enabling the bidirectional communication we were not able to do in the past. And it's great because it starts with HTTP or HTTPS and then upgrades to WebSocket, provided both the web browser as well as the web server support the protocol. This is the perfect solution when servers need to push updates to clients. WebRTC, on the other hand, is all about connecting peers directly. And this is really great if you're doing any kind of an app with streaming audio and video between folks. Maybe you're communicating arbitrary data, and perfect example or use case for that is just video games. They're doing this all the time. And so when you cut out the middleman and connect the clients directly, you greatly reduce redundancy. Now, the only drawback maybe to WebRTC is that it requires a turn server to get the clients connected directly. But once that's taken care of, it's pretty great from there. One of the reasons you might choose not to use WebRTC just yet is just current browser support, depending on if you're still working with IE, hope you're not, or maybe even Edge 14. There's no support there, older versions of Safari, and so on. The support's just not that great. However, WebSocket, on the other hand, has a whole lot more green. And so unless you have to worry about supporting Opera Mini, you can go ahead and use WebSocket just fine. Here's an example of what WebSocket technology looks like. So this is some JavaScript code, and on line 2, we're declaring a variable called socket, setting it equal to a new instance of this WebSocket object, and just passing in the URL import for our web server. Now, that socket instance is an event emitter, and so we can set up event listeners on events like open and message. Now, open is when we first get connected to the server, and we can use the socket then. It has a send method, and we can send data down to the server. In addition, we can listen for the message event, and that's when the server's sending us some data, and we can use the event object to access that data and log that data out. So this is sort of the very basics of WebSocket in a nutshell, if you will. And now that I've shown you this API, I want you to promptly forget it. The reason is that, like any good protocol, WebSocket's a very low-level protocol, a very tedious protocol to work with, and so you're unlikely to work with it. Instead, you're going to use Socket.io. And Socket.io is 2 parts. There's a client-side part and a server-side part, and I'll show you both of these as we go through some of the code in a bit. Basically, Socket.io is, in a sense, its own protocol, because it will start with long polling, so it can support older browsers and then upgrade to WebSocket when possible. And it's a very simple API with some great features, multiplexing, different rooms if you need that kind of support. But one of the things I really love is auto reconnect. I'm based out of New York City, so if you get into the subway and you come back out and you need to, you've just been disconnected from the server and you open the web page again, well, who wants to write the code to do the reconnect, right? So Socket.io manages a lot of that kind of stuff for you, so it's a really nice tool to work with. All right, we're going to do 2 code reviews. In this first code review, I'm going to show you some of the code I used to put together the client application as well as the public API. And then later we'll look at the database code as well. So this is my application, the real-time demo app. And you can see here it's split up into 2 parts. And so I do the dev for the client in this directory here, and the source is here. And it's basically an Oracle Jet application. And I used a certain, like a Yo generator for Oracle Jet so that I can do some things out of the box without a whole lot of code. What happens is I take the source code and I use Bower build to build the project, and it generates this web directory. And I end up moving the files in this web directory to the web server. But I'll show you the source code. We'll go into the JavaScript directory here. And I guess we'll start with the main.js, since this is really what kicks things off. Let me make this a bit bigger. Hopefully everybody will be able to see this. All right. So the first thing you'll notice is that the main.js is calling require.js config. And so Oracle Jet clearly uses require.js as its module system. And down here, you'll see that I'm exposing socket.io, and I'm telling require.js the location of the socket.io library. So I used Bower in this particular case to install socket.io. That doesn't sound right, not Bower. I used, let's see here. Yes, sorry, it was Bower to install socket.io, and it's Grunt to do the builds. Apologies for that. Okay, so at any rate, I'm bringing in socket.io here, and then I'm able to reference it using require with socket.io. So the next thing I want to show you, going back into our JavaScript, is this module here. This is called app-socket. And as you can see, it's a very simple file. And it's a defined block that's a require.js define. So these are the modules. These are my dependencies for this module. Notice one of them is the socket.io library. And so I bring in socket.io, and socket.io is just a function, and I'm invoking socket.io. This is very much like what you saw with the WebSocket protocol. I'm just pointing it to my server and port. So then I get this instance of socket.io, and I return that out. The reason I do this is that I really only need a single instance of socket.io that I can share throughout the entire application, and this is the instance here. And the module is app-socket. All right, let's continue on. So the page that everybody was voting on, this page here, the Super Cities page, that's here. So I'll show you real quick that the way Jet organizes its modules is in two different directories, views and view models. And so the views are what we're seeing, the HTML templates, and the view models are the data and the logic behind those templates. So if we go into views in Super Cities, can open that here. And what most folks were seeing was this single div here. This is actually, you could think of this as the entire web page. And so there was that question at the top, what's your favorite city? And then the only other thing that was there was this unordered list. But this data-bind property here tells us that this is actually an Oracle Jet component. And the component type is list view. And the data here is pointing to a data source, Super Cities data source. Also, for the items, I'm providing a template. And note that this ID matches this ID here. So this is a script tag that brings in a template. And notice it's an LI element. So basically, what's going to happen for each element or city in this array, the LI will get injected into this unordered list. But each one will be unique because, of course, we'll have the properties of the city, such as the rank, its current rank in the voting. We'll have, for example, the name of the city, the number of votes that that city has. And then down below, you'll see the vote button, also an OJ component, and it has an event handler for the click event going into the parent scope and invoking a function upvote. So where does that come in? Well, of course, that's from the view models. And we're looking at Super Cities JS here. So again, another defined block. These are the dependencies in the top array. And then this function here basically defines our view model. So let's see here. The first thing I'll point out is the data source. This is that array that you saw referenced in the HTML file. And so I initialize it just to an empty array. Now, OracleJet does have some lifecycle methods for the view models, like handle activated when you first go to the particular view. And so I'm using this to issue an Ajax request. This is jQuery's Ajax method. And I'm going to the API root. And so that'll have a slash and then this super cities endpoint. And I'm getting some data. And then I'm just sorting the data so that we display it in the correct order. And then I put it into the data source here. So really that's all I have to do, and then the view will automatically reflect the data in that data source. Further down below, you see a handle attached. I had to disable some animations for this particular app. Here you're seeing that upvote function that we saw a moment ago. So when you click on a vote button, it invokes upvote. And all this does, again, using Ajax, it goes to the API root / supercities, only this time, appending on a little bit more in the URL, the city ID / votes. So that's the full path, and we're issuing a post on that particular URL to just add one more vote. A little further down, you'll see, actually, let me scroll all the way up, and I'm just going to show you one of the dependencies I brought in was that app socket module that I showed you before, the single instance of socket.io that I brought in. So I brought it in, I renamed it to IO, and you see it down here. So I'm using this to listen to an event, and I'm saying on cities.change, and I know that when this event happens, I'm going to get some data. So I just parse it into JSON, get the items, and then I go back to the data source, and I just pass it those items to update the data set, and of course then the view will reflect the current data. So this is really all it took as far as the client side to get things working, except of course for the admin screens, which I won't cover. Let's go ahead and move on to some of the server side of things. Don't need that anymore. Okay, so I'm going to come back out into the server side. So remember I said that I take the web directory that's created when I do a build and I host the files. This is that web directory, essentially. This is the end result that I need to host. And I have a bit more going on in here. This is obviously a Node.js application. So in Node.js, we typically start with something like an index or main.js or an app.js, something along those lines. So this is the main here. A couple things I'm bringing in, the Oracle database driver. I'm bringing in Express for my web server. And I'm also bringing in a couple of files. So I'm bringing in a public API as well as a database API. Now, the browser is going to communicate via the public API. And the database, when a change occurs, and we'll talk more about this a little later, when a change occurs, the database is going to talk to the web server on the database API. So that's why there's two APIs. If I scroll down a bit here, I'll just point out a few things as we go. Node.js has a thread pool for doing various things. I increase the size of the thread pool depending on the size of my connection pool to the database. Just lets more connections work in parallel or concurrently. Down here, I'm creating a pool with the database driver. If you're doing a web server, this is absolutely something you want to do. You can't just do the one-off or dedicated connections to the database. You're going to want a connection pool. A little bit further down, you see init web server. So when I invoke this, I use the Express module. I invoke it to get an instance of an Express application or web server. And the way that it works with the web server and Express, it's use this use method to add in various middleware components, as they're called. And so the first one I'm adding in here is called Morgan. As you can see in the comment, Morgan is logging software, and the combined parameter here will combine a little bit of output from the request coming in as well as the response going out. So it looks a bit like an Apache log. Down a little below, we have body parser for JSON. So this knows how to parse incoming JSON bodies into actual JavaScript. Down below, we have the way that the web server works. Remember, where all those static files were for the application, they're in this web directory. Well, if I want to use Express to host those static files, I just use the static method and point to the directory where those files are. And this is just the root path. So when a request comes in on the root path, it'll send out the index.html, and then of course all the other requests will continue on from there. A little further down, you're seeing I'm using some custom middleware. This is just a handwritten function. And all I'm doing is adding some HTTP headers to the response and essentially enabling CORS support. And I did this because I was testing locally, deploying to a different port. So this just makes things a bit easier. And further down, now you see where I'm mounting the API path for the public API. So we're saying app.use. Here's the mount path, and then from the public API, I'm getting this router here. So let me head over to the public API directory, and we'll open this file up, and I'll show you what the router looks like. So again, I'm bringing in the driver as well as Express, but this time the only reason I'm using Express is to create a new instance of their router class. So I have a new router, and I'm exposing that so that it can be consumed in the previous file in the index.js. But I use the router route method and pass in the route. So if you look back to the API mount point, so if a request comes in on /API and then /supercities, and that request is a GET request, an HTML GET request, then this function defined here will handle that request. And so what I do, I use the database driver to get a connection from the connection pool, and then I execute this SQL statement here. And you notice that I'm going to the supercity votes table. I'm getting, I'm going to the supercities because that's the endpoint. I'm getting the ID and the name as well as the total number of votes for that city. And then I'm using some analytic stuff just so that we don't have to do that on the client side, getting the rank and the total votes. So once that query is executed using promises here, I'll get the response or the result, and I can then close the connection and then use res to send the HTTP response. It's a status 200 OK, and then I use the rows property on result to send out that JSON. Down below, you see the other endpoint, and this is for actually casting a vote. So I'm routing any requests that come in on this path, but the post method in this case, and again, getting a connection, executing the insert into the vote table for the given city, and then we just send back a response to a 1 and end that. So that's sort of the public API in a nutshell. If you've never seen how to code such an API in Node or Express, hopefully that will make some sense. All right, I feel like I know there's a bit of a delay, but just in case, I'll ask now, does anybody have any questions about what we've seen so far before we move on? And because of the delay, I'm just going to wait 20 seconds or so, and then I'll continue on. Okay, I don't see any questions. So let's go to the next step now and talk about how we can get the database involved in this interaction. There are two parts that you're going to need when involving the database. First, you're going to need some kind of events mechanism to detect when a change to data has occurred. And then you're going to need the ability to communicate out to the web server when that event occurs. So what do we have available? Well, when we hear events in the database, oftentimes people immediately think of triggers for good reason. With Oracle, we have two main types of triggers. We have DML triggers and system triggers. Most folks are familiar with DML triggers like before insert and after update. System triggers are a little lesser known, but you can do things like after a user logs in or before an object is dropped and so on and so forth. Well, we could have used an insert trigger, right? So here's an example: create a replace trigger, notify on new vote. And so this is an after insert on supercity votes table for each row. And I'm just leaving what we would actually do to notify the Node.js server blank right now. But this particular trigger would work, but it wouldn't work very well. And the reason is because if we're notifying the Node.js server, we're obviously doing that over HTTP. Most folks think about different types of I/O and the speed that they take. There's a really somewhat famous anyway image out there that talks about the difference between, say, I/O and level 1 or level 2 cache, and then RAM, and then disk I/O, and worst of all is network I/O. And so what we're doing here is saying, all right, when an insert occurs, which is disk I/O, then fire this trigger and do some network I/O as well. So this would be a really bad idea, right? It would just, all the inserts would go really, really slow. So don't do that. All right, so what's the next thing we have in our toolbox? Well, you might also look at the scheduler package. And this is sort of like a second generation package for scheduling. We used to have DBMS jobs, now we have DBMS scheduler. And scheduler is really powerful. Here's an example of what you can do with it. So we're just saying DBMS scheduler create job, and you specify a few things. Now, we give it a name, and this particular type is a PL SQL block. So I just put an anonymous block here, and I say, do something awesome, right? This could be anything you want it to be. And we can schedule this to start on a particular date. And this repeat interval is what makes scheduler so powerful. It takes a calendaring syntax here. It says frequency equals daily, but you can get really flexible here to schedule all kinds of different jobs. And the truth is that you can create certain jobs that aren't necessarily intended to be invoked on a regular basis, but instead called when you want to call them. So here's what something like that might look like. So imagine we have this procedure, notify Node.js, right? We create a named procedure, a stored procedure. And again, I'm not showing the implementation just yet, but just know that this particular procedure would notify the web server when a change occurs. Well, here's the trigger we could use that would work a little bit better. I need to add the pragma autonomous transaction, which makes this what the trigger is doing, essentially a transaction within a transaction. And then we can call DBMS scheduler create job. But I can just say job action and then point it to the stored procedure up above. Now, this will immediately start the job. But the advantage with DBMS scheduler is that it essentially does the work here asynchronously using a background process on the database server to do that. In other words, it's not necessarily going to be part of the overall transaction, which is good. Another tool within Oracle Database that we can use is advanced queuing. And if you've never seen going the wrong way. If you've never seen advanced queuing before, it's a really powerful feature of Oracle Database that provides a queuing framework based on tables for persisted queues anyway. It's super flexible. You can set it up to do point-to-point messaging, or you can do pub sub, that kind of stuff. The truth is, for my particular implementation, it was a bit overkill, so I didn't want to use advanced queues. And I got lucky. I found yet another feature in Oracle Database called continuous query notification. This is one of those lesser known but super powerful features that I think everybody ought to take a look at. So here's what it looks like. And this is just an anonymous block. We're declaring a few variables to start. And the first of which, it's reg info, and the type, this is an object type. It's a registration info type for the continuous query notification feature. Down below that, I declare a cursor, just a sysref cursor. And down here, I'm setting the reg info. Here I'm instantiating the object type, the registration info, and I'm passing in some parameters. Now, the first parameter is the name of a stored procedure that you're going to want continuous query notification to invoke when a change to data has occurred. There's some quality of service. There's some timeout stuff in here. I'll talk a little bit about these later. Well, actually, I'll talk about timeout. No, I'll talk about it later. All right, so let's go on. So now down here on line 15, I'm using the DBMS QC notification package, invoking the new reg start and passing in that reg info parameter here, and basically starting the registration process. And then all I have to do is open a cursor. Note that I open and close it. We're not actually executing the cursor, but we open the cursor and we just specify the query. In this case, you do need to include the DBMS CQ notification query ID, but then you just add different columns that you want to listen for changes on. And so when a change occurs, then this procedure gets invoked. So then all you need to do is close the cursor and end the registration. So once you figure out the event side of things, you can move on and figure out the communication side of things. Now, for the longest time, we've had a lot of packages within Oracle to communicate out. TCP, HTTP, SMTP, and mail packages have been available for a while, but I actually didn't use any of those. Instead, I opted to use Apex Web Service. Apex Web Service is a package that comes as part of Application Express, or Apex. It may be in your database already. If not, you can install Apex for free. But the reason I chose to use Apex Web Service is that it's the easiest way to do REST from Oracle Database. So this is what it looks like. Now I'm actually showing you the implementation of Notify the Server. Now, Notify the Server does have a certain signature, and this is something that the notification service is going to expect. And what it's going to do when it invokes your stored procedure is pass you some information about the change that actually occurred. I'm just not using it here because to me, it's not important. If a change to the data, in other words, the number of votes has changed, then all I'm going to do is notify the web server. And the way I do that, I just declare a CLOB, and then I say Apex Web Service make web request, pass in the address to the Node.js server, and actually the database endpoint, whatever it may be, and tell it what method to use, in this case get, and that's really all I need to do. So Apex Web Service is definitely a great tool. Highly recommend that. Let's take a look at a code review for the database. So actually, I'll go just a little bit further down. Don't need the public API anymore, but I'll go a little bit further down in the index.js. Remember that this is the Node.js web server file. So right below where I mounted the public API, you'll see that I'm also mounting the database API and the database router. I also go to the database API and I call this init HTTP web server. And all I'm really doing is passing the web server into that database API. So let's go look at that database API. And I'll show you why I'm doing that. Okay, so here's the database API. And I'm bringing in the Express Web Server. I'm also bringing in Socket.io. Now this is the server side component to Socket.io. Remember, it's two parts, server side and client side. The client side I installed differently. This one I just npm install it, but then I use it very much like what we saw before. All the init is doing is taking that web server and it's invoking Socket.io. Again, it's a function. I just pass in the web server, and I get back this IO or instance of socket IO. And I only needed one. And the reason I did it in this context, I could have done that in the index.js, is because I just wanted a reference to this IO. So it was just a scoping thing. And the reason is because I use the IO in the router functionality. So let's go through this. So this is the database API. So database db underscore API slash supercities. When a GET request comes in on that URL, then this function gets invoked to handle it. So what it does is actually goes back to the web server's, if you can see it over here, the public API. So it just knows once that GET request comes in, we know a change has occurred to the data. So now I'm simply using the public API to go back to the database and get the current, most up-to-date data from the database using the regular API, the public API. And then once I have that data, I can then, once I get the data in the body, I can then use the IO instance and emit. And this is that event you saw I was listening for on the client side. I'm emitting the event name as well as the body or the new data. And then I just end that response. Let me show you very briefly in SQL scripts. So this is the code I actually used to set up. It's similar to what you saw, just maybe a bit more verbose. And what we have here, I wanted to show you this because if I go back to the dashboard, note that a total of 1,210 votes were cast, but only 65 updates were pushed to the browser. This is really important. If we were sending HTTP or WebSocket pushes to the browsers every single time a vote was cast, it just would not work very well. It's too many pushes going out to each client. So the way I was able to achieve the reduction is using some of these flags that QC notification supports. So when you're setting up your reg info and you tell it, of course, the stored procedure you want it to invoke, the one you want is timeout. So timeout is the number of, I'm sorry, not timeout, it's the grouping rather. So down here, what I'm doing is grouping by time, and the grouping value is 1. And this is a number of seconds. So we're basically saying any changes that occur within the span of 1 second, we're going to treat that as a single event or change notification. So you can adjust that as needed. And then down below, this is actually what my code looked like, a little bit different than what you saw in the example, simply because I am hitting on HTTPS, and if we want to do that from Oracle database, we need to use a wallet. And so, of course, I have that working here. You'll also see in the real example that I'm using Logger. And if anybody here is not familiar with Logger, you really should be if you're doing any kind of PL SQL work. Logger is a go-to logging tool. It's open source. You can find it on GitHub, but it's a very well-written logging tool for Oracle database and PL SQL. So if you're not yet familiar with that, definitely get into it. For me, the reason I brought it in to the mix is because whenever you're dealing with these sort of asynchronous events kind of things, it's like if an error occurs, how do you find out about it? Well, Logger will let me know if an error occurs. Cool. So I think that's all I wanted to show you on the database side of things. So like before, I'll just wait a few seconds to see if anybody has any questions before continuing on. Now, the last thing I wanted to show you is native driver support. And this kind of goes back to the safe harbor slide I showed you at the very beginning. This is not current functionality. This is potential future functionality. But I think it's super cool, so I wanted to show you what the future could look like. So you've seen this PL SQL implementation or use of this great functionality of Oracle Database, CQN. But wouldn't it be great if we didn't have to use PL SQL at all? So what I have here is a mock-up of what it could look like in the future when we add support for this feature directly in the database driver. So forget about all that PL SQL code. This is just JavaScript. So I'm bringing in the Oracle Database driver. I'm bringing in Socket.io. And I use the driver to get a connection using the config info here. And this is one of those one-off dedicated connections to the database. Once I get that connection, I use it to invoke a method that does not exist, but it's called create subscription. So these parameters here are very much the same as the ones you saw in the PL SQL code, only this callback here is not a PL SQL stored procedure, but rather a JavaScript function. And that function is defined below. But before I show you that, I'll just show you that what you would do is create the subscription object with these parameters, and then you would get that subscription and invoke something like register query and just pass along the query, and then this subscription object will start to listen for changes. When a change occurs, the function below that you set up in the callback will be invoked. So what is that going to do? Well, just like before, it's going to get a connection to the database, select whatever data you need, and then send that back out. So we can just do things a bit more directly than we'd be able to do without this support. But you can do it the PL SQL way already today. All right, well, that's all I have for you. If you're interested in learning any more about any of these technologies, the last slide in the set here, I just added a bunch of links to the various technologies. Of course, that's Oracle Jet. On the client side, we have Socket.io on both the client as well as the Node.js side. And you might want to learn about Node.js if you're not familiar with that technology yet. And then, of course, to all the various technologies I showed you that are in Oracle Database. All right, I'll open it up to any questions. And while we're waiting for any questions to come in, I'll just let everybody know that if you're interested in the code or the slides, please feel free to reach out to me via the email address I showed you in the beginning, or via Twitter, or when this recording eventually makes it online, I'll also put some links in the comment section there as well. Okay, I'm not seeing any questions coming in, so I think we'll go ahead and end it there. Just wanted to say thank you all very much for coming, and good luck building those real-time applications. Take care.